All right, here's FRQ2. Sorry, I just put some chocolate almonds in my mouth. Probably should start the movie over, but I'm not. All right, input, say it. Output. So 0, comma 24 is a point, and then 10, comma 7. So you start at 24 degrees Celsius at time 0. After 10 minutes, you're at 7 degrees. So the first thing they ask you to do is find two different models with those points. So 0 for T, 24 for Celsius, 10 for T, 7 for Celsius. And I believe they just let you leave that alone. Um, you don't have to start simplifying there. But then they do say find A and B for step 2. Putting a rubric off to the side there, how many points each one. All right, so first of all, when you plugged in 0 for T and got ln of 1, ln of 1 is 0. So 0 times B is B. Sorry, 0, blah. And then that means A equals 24, your initial value. So there you go. A is 24. Then you use the second model to find B, since I now have found A. Subtract 24, divide by ln 11, beep boop, bop boop, type it on your calculator. That's the noise for calculators, by the way. And then you get that answer. Okay, so we can now have this model. And actually, I do type the model in my graphing calculator for a later question. But then they go off target here a little bit, or off the rails a little bit. And part 2 asks for average rate of change between these two coordinates. Or sorry, part B 1. So those two coordinates, you just find the slope of those two coordinates. Should not have to describe that. I will say this for letter B2, I went ahead and found an equation of a line then using that slope. And you know what, by the way, 24 is the y-intercept anyway, but I just wanted to show point slope form one more time. And then using the average rate of change, what would 13 give us as an output value? All right, well, I plug in 13 into my equation for x and solve for y. So 1.9 degrees Celsius, 13 being 13 minutes. That's why we get that answer, 1 point. Now, many different ways. I'll just show you what their answers say, like the written sentences, the Valente person. Thank you again, Mr. and Mrs. Valente. I don't know who you are, but we stole your questions from the internet and use them in our class. Thank you. Much appreciated. But I graphed the function itself, the log. You could see it, y equals in blue. And then graph the linear function from the average rate of change idea. And then here's 13 comma. So they're asking which one would be higher. Is it higher or lower with the average rate of change function? And it's lower, all right? And I think that's one thing you could do for a description. You could say you get 1.9 in the average rate of change for degrees Celsius, but in the model you get 5.29 degrees Celsius. So the average rate of change model is lower in prediction. But then they also talk about this, the concavity of the actual graph. So it's decreasing at an increasing rate, kind of thing. I don't know. Just go ahead and read that sentence. I'm sure many answers can vary. I just think the input output and comparing the two output values should be okay. But, I guess I'd have to read that question a little bit further. Explain your reasoning. That's means fun rate less or greater than temperature predicted by the model. I don't know. I feel like that should be okay, but we will see, I guess. And then this range thing is kind of weird. It doesn't say anything in there that the temperature of the freezer is set at 0 degrees. All right. I think that's what this is implying. Remember, it started at 24 degrees and goes down. My freezer at home, I set it at 1 degree. Nobody cares, Mr. Samulus. But nothing is written in the question about what the temperature is set at the in the freezer itself, because that's what the temperature would come to. So I guess that assumption is made. And with that being said, what's the domain? Well, the domain is from 0 for time, that would be at 24 degrees Celsius, to how much time it takes to get to 0 degrees Celsius, which means you would have to find this x-intercept. So I'd have to expand this graph a little bit and see what ends up happening when we reach that 0 degree temperature. right? And then that comes to be 28.5257. So that's why that's the domain. All right. So I guess the assumption is made that you set the temperature of the situation at 0 degrees. And that is a good little quote, inspirational.